Hello, Andy. It's about time.
Okay.
Okay, so one more minute. Oh, okay. Shall we start now?
Yeah, if you're ready, I expect
Yeah.
you're very punctual in China.
Yes. It's 6:15 now. Okay,
Yeah.
so dear students, colleagues, and friends, good evening. Welcome to the Translation and Interpreting Studies online lecture series hosted by the Division of Translation Studies at the Chinese University of Hong Kong, Shenzhen. Today, we have a thought-provoking lecture on large language models and translation. Should MT developers and human translators be worried? And it's my great privilege to introduce our distinguished guest speaker, Professor Andy Wei. Professor Wei is the Deputy Director of the ADAPT Center for Digital Content Technology at Dublin City University, and with an illustrious career spanning over 3 decades, Professor Wei has been recognized for his outstanding contributions to the field. He was the recipient of the 2015 DCU President's Research Award for Science and Engineering, and in 2019, he also received the extremely prestigious Award of Honor from the International Association for Machine Translation for his services to the community. At the ADAPT Center, Professor Wei leads the machine translation team, collaborating with prominent industry partners such as Microsoft, eBay, PayPal, and Huawei. His expertise and leadership have been instrumental in shaping the field of machine translation. Professor Wei served as president of the European Association for Machine Translation from 2009 to 2015, and was the president of the International Association for Machine Translation from 2011 to 2013. He also served as editor of the Machine Translation Journal from 2007 to 2021, with over 450 peer-reviewed papers to his name and an H-index of 49. Professor Wei's research has made a significant impact in the field. Drawing on his 35 years of experience, Professor Wei will provide on the implications of large language models in translation and explore whether MT developers and we human translators should be concerned and offer valuable insights into the future to the field. Okay, so now let's warmly welcome Professor Andy Wei.
Thank you, Shigen. You're very kind. Thank you for the invitation and for your very kind words. To the audience, thank you for attending. I know you've been working hard all day, so I'm trying to keep this a little bit lightweight, and hopefully it'll be entertaining enough. It's early in Ireland here today. It's before lunch, and I'm keeping you from your dinner, so I will try to keep on time. When Yin says I have 35 years of experience, what she's really trying to say, very politely, is that I'm quite old, and I've been around for a long time. And of course, this sort of thing happens all the time. Like there have been many paradigm shifts in machine translation over the years. I've been around for many of them, which is a good thing and a bad thing. And often, whenever there is a paradigm shift, people come out with they overhype the technology, and translators start to get worried. And this has happened many times before, as we saw the change from rule-based to statistical machine translation, and then the change from SMT to neural machine translation. And now we've seen tools like ChatGPT come along, and people are again overinflating, in my opinion, the claims, the performance benefits of these systems. And certain people are starting to say that translators will be redundant very soon. I don't believe that to be the case, and I hope to demonstrate why over the next hour or so. So let's get cracking. The first thing I want to sort of bring you with me on is the fact that it's uncontroversial these days to say that machine translation is here. It is being used by hundreds of millions of people on a daily basis, translating billions of words each day. So this is from 2016, where every year Google has a summit where it showcases its products and services. And even in 2016, you can see here that over 143 billion words were being used by were being pushed through Google Translate every single day, yesterday, today, tomorrow. And of course, that's probably risen to 200 billion words a day or 250 billion words a day. So, and this is just one provider, albeit the single biggest provider of machine translation on the planet. So, there have been people in the past, commentators, saying that there's no room for machine translation. Machine translation doesn't work. People like to show on the web or on chat, social media platforms, they like to highlight the cases where machine translation goes wrong. Sometimes that can be quite amusing. Sometimes it can be, rather insulting. But they don't showcase all of the times that machine translation works successfully for them. So, arguing that machine translation is useless, I think, is pointless today. So, if we can accept that point, it is of no doubt that machine translation has been overhyped for many years. But as soon as neuro machine translation came in around sort of 2015, 2016 or so, people started to overinflate the capability of machine translation, of neural machine translation. So there was a paper by Google in 2016. You can see the date there on the left-hand side of the slide. And the scary words of the title are bridging the gap between human and machine translation. So as soon as you see words like that, commentators, start to overinflate the claims of machine translation, and human translators start to get worried. So here are some of the, these are real web pages at the time. It's nearly indistinguishable from human quality. It's as good as a human translator. It's a miracle. It's approaching human level accuracy, a major breakthrough, etc., etc. It can translate almost as well as humans can. So, that goes with the territory. And then translators, unsurprisingly, start to get worried. And these are real, again, web pages. You can find them yourself if the URLs are still up and running. Will neuro machine translation replace human translation? Can NMT compete with human translation? What does the future hold for translators? Removing language barriers, etc., etc. And you're going to see later in the slide deck, much the same things happening when we move from neuro machine translation to large language models like ChatGPT. So clearly these things are useful, but they need to be used properly and in the right context by the right people. The hype was inflated again by a paper from Microsoft Machine Translation. So you saw with Google, they were bridging the gap, but Microsoft here, they seize the nettle, they grasp the nettle and say that, they've actually achieved human parity. So what they are saying here, for, Chinese to English news translation, their system, their neuro machine translation system is as good as human translators. So again, the hype starts up once more, and we can see some of the claims in the literature. So historic milestone, achieving human parity. It's a huge breakthrough. Human parity achieved. And again, the great thing about this, the Microsoft paper compared to the Google paper, was that they made all of their data available. All of their translation outputs, all of their human translator ratings, on a sentence basis. So we were able to take that data and try to validate Microsoft's claims ourselves. So in my team in DCU, with an ex-colleague, Antonio Toral, and at the same time, this was being done by colleagues in Edinburgh and Switzerland. We both showed in separate papers, which were published within a day or so of each other, why we believed that the claims from Microsoft did not hold water. So we were able to show what the problems were using their own data with those claims. So again, you can have a look at those papers later on if you haven't seen them already. And again, here's another claim. After that was March 2018. Here's one from June. Again, SDL, one of the biggest translation providers one of the biggest language service providers, posting an article on its webpage saying that SDL cracks Russian to English neural machine translation. So, I'm a native speaker of English, and in my dialect of English, if you crack something, you really do solve that problem. The problem has been solved. It's like cracking a code. Like you're trying to crack an enemy's code. You actually understand what their message is. And again, this is hyperbole. SDL really haven't cracked the problem of Russian to English neural machine translation. And if they have achieved good performance, it's probably only in certain application domains. So it will not be the case that SDL's Russian to English NMT system is perfect, for any input you can envisage. So, this has happened quite a lot, during my lifetime in machine translation. We've had, translators, pushing back, quite understandably, against these claims. And, people like me who are in the middle, trying to, educate people and tell people, what the truth actually is. It's a real pity when people overinflate the claims of the technology, because, I'm one of the people who produce that technology. We publish papers in conferences and journals, and we participate in shared task competitions. And, when users come to see the output of our systems, given these overinflated claims, they can be disappointed. Their expectations are very high, and those expectations cannot possibly be met, because of the hyperbole associated with the claims of performance. And it's unfortunately the case that, ever since machine translation systems were built, in the very first one really was 1954, the Georgetown system. After the war, Warren Weaver, an American scientist, was talking to a British computer scientist, Andrew Booth, about the possibility of using, cryptographic techniques, from a purely algorithmic perspective, using no human knowledge whatsoever, no linguistic knowledge, could, for example, Russian be translated perfectly into English. So again, people started to build systems. Again, the very first system had only 6 grammar rules and 250 words in the lexicon. And, there was a demonstration of its performance, and people got, again, carried away with the capability of machine translation. And of course, once they actually began to interact with that MT system, the cracks started to appear. The output could never be anywhere near as good as people were predicting it to be. And, rule-based systems, took over, very good systems like the Meteo system in Canada, which translates on a daily basis, weather forecasts between English and French. In Canada, it's probably the best MT system on the planet. But you can see there, it's an MT system for a very specific sub-language, that of weather forecast. So that works well. Rule-based translation, was the dominant paradigm for many, many years, but it really didn't work very well. The rules were brittle. If it was confronted with input that it hadn't seen before, or the linguistic content of the input did not accord with the grammar rules in the system, then the system would fall over and translations would not be output. So statistical machine translation came in the late 80s for English to French, one of the easier language pairs deliberately chosen. And again, this was a real shock to the system for all of those people doing rule-based MT at the time. So it worked, pretty well for many years. People started to build systems around the Moses platform, which was released in 2007. And lots of LSPs produced commercial machine translation systems of good quality around the Moses platform. And then, neural machine translation started to kick in. The first systems started to be built around 2013. Again, because we had sufficient data sets and the performance of our engines started to improve because the hardware, we had GPU hardware for the first time. So, large scale models, using neural processing started to be built. And around 2016, people started to show that, NMT was superior to SMT. So, and that's where we are. This graph, obviously, we continue that on for a few years now. Neural machine translation would start to dip with the onset of large language models like ChatGPT. So, and again, maybe, at the end of the talk today, you can decide yourselves whether we are starting to go down, whether the expectations of large language models like ChatGPT is starting to go down, or whether we are still on the incline. So why, in a nutshell, I'm not going to give you a lecture on how neural machine translation or statistical machine translation works. But essentially, in one slide, and I was talking to students yesterday in Dublin, and I use the same slide. Why do I think neural machine translation works better than SMT, than phrase-based SMT? Well, in phrase-based SMT, what we used to do was break up the source string into words and phrases, try to identify some target words and phrases which were translational equivalences of those source words and phrases. And then we would try to piece them together and smooth that using a target language model into the best output that we possibly could. So you can see there that we have, submodels of words and phrases. We know what tomorrow could translate as. We know what I could translate as. Will fly could translate as. To the conference could translate as. But we don't have an overall model of the full context, if you like, of that sentence. But we do in neural machine translation. So, we have a neural network which processes the whole of the input string, okay, produces a hidden state of the network, which is itself then passed over to the target side neural network, the decoder, to try to produce the best target language output that we possibly can. So in neural machine translation, we actually do have a model of the entire source string. And because of that to me is the biggest reason why neural machine translation output is better than statistical machine translation output. Now you can see for this input string, we get the same translation for with SMT and with NMT. But if you do a large scale study, on the whole, we can see that neural machine translation outputs are better than SMT, and it's probably for this reason. One of the problems, though, is that with neural machine translation, we require huge amounts of data. So it used to be the case that people thought that SMT required lots and lots of training data to build its models. But then we found that in neural machine translation, we needed even better, even larger amounts of data to train up our models. So here's a study from 2017 and a graph from Knowles and Kuhn, which shows you that, with, let's say, 1 million words of training data, that the neural machine translation system significantly underperforms compared to a phrase-based SMT baseline, and even, considerably worse than that same phrase-based baseline with a large target language model. As we increase the training data size, so we go from 1 million to 10 million, you can see that the green line is very close now to the middle blue line, but it still hasn't reached that performance. When we go to 100 million words, okay, the green line has passed through the blue line, but it still hasn't quite reached the top line, which is the PBSMT model with the large language model. But then when we add more data, you can see that the performance of the neural system starts to surpass that of the of even the phrase-based system with a large language model. So, but the point here is very clear, that we need large amounts of data. So I think, like while I'm speaking, you can ask yourselves the question, like how well can neural machine translation work on my language pair, whatever your language pair is. People are very quick to say that, for example, machine translation is now a solved problem. Well, for how many scenarios, how many language pairs, and how many application domains do we have, 100 million words? So just ask yourself that question as we're going along. Here is, more or less the state of the art. We have 3 neural networks, one for the source, one for the target, and then we have this attention model in between, which helps the decoder focus on other words in the input string, which could be of benefit when trying to translate a particular source language word. So the usual example we use in machine translation and translation, and in linguistics, is the word bank. So a bank can be like a river bank, or it could be a financial institution, somewhere where you give them your money or you borrow money from. And again, if you are able to look at other words in the string, such that one of the words, for example, is river or water, then you might choose to translate bank as river bank in the target string. And if you see money later on in the sentence, or previously in the sentence, then you might translate it as a financial institution. So this is pretty much the state of the art today. Three neural networks all working hand in hand, one for the source, one for the target, and one relating source and target words, multiple source words to possible target words. And the attention model has become so powerful in what we call the transformer model. This underpins pretty much all language processing, including machine translation, and is the same technology being used today by ChatGPT. But these networks are massive. Here is I don't have to persuade you, I don't think, that having a system that can recognize handwritten single numbers, so from 0 to 9, this is how complex that network is. That's a relatively simple task. And again, this is a task which is beneficial. For example, post offices around the world now automatically read postcodes on envelopes, for example, and they need to be able to read the way that I write numbers, or the way that Shuyin writes numbers, or the way that any one of you writes numbers. We all write these numbers slightly differently. And here is this, what the size of the network, a fully connected neural network, to do that would be. So you can imagine how complex the neural networks are to process, one human language into another human language. These things are absolutely enormous, with many, many nodes and many, many layers. So the processing requirements for neural machine translation and large language models are enormous. So here's a graphic from Chris Manning, who you've again a big name in natural language processing, where he's saying, this is the progress. We are making progress, incrementally, if you like. But the problem remains the same. I don't want people to get carried away with sort of neural networks or even large language models. What we are trying to do is, say, translate from Chinese, let's say, into English. And whether you're using rule-based processing or statistical processing or neural machine translation or large language models, we have the same problem. We're just going about it in different ways. It's just different architectures, different models, different ways of trying to solve the same problem. And while neural machine translation quality is better than anything that we've seen before, we don't yet understand exactly why. So we're trying to, people like me and Shuyin, we like to understand what's going on so that we can explain it to our students. And at the moment, it's very hard for us to understand exactly why, our outputs, with today's systems are better than with the outputs of previous systems. But we are getting there towards explainable AI, and I'll come back to that towards the end. But there are lots and lots of problems remaining. Don't think that all of these things are solved. There are many topics for student projects, PhDs, for clever people like you to come along and help us out solve some of the problems that we haven't been able to solve so far. So Okay, coming, much more up to date. Chat GPT. There was a lot of hype. This, you can see the dates on these on the slides. This was only March. Okay, and I, in coming up with some ideas for this talk, I wanted to show you, what sort of hype was associated with ChatGPT when it first came in. So this is March this year, so only 6 months ago. And you can see that both of these examples that I've chosen, one from The Economist and one from LinkedIn, two notable platforms, they use the word marvel. So ChatGPT is a marvel of multilingualism, introducing the new kid on the block, ChatGPT-4, OpenAI's latest AI marvel. So if something is, if it's something that you marvel at, it's almost a miracle. It's so good that you can't believe your eyes. Yeah. So look at the words, the hyperbole that's being associated with ChatGPT when it first came in. And then you have people like Zuckerberg, the head of Meta, Facebook, coming out with quotes like this: the ability to communicate with anyone in any language, that's a superpower people have dreamed of forever. And AI is going to deliver that within our lifetimes. Okay, well, I'm older than most of you on this call, but I'm quite confident in saying that it will not deliver that within my lifetime, and it arguably won't deliver that in your lifetime either, and it probably won't deliver it in anybody's lifetime. These sorts of things are said by people who don't really understand, how hard the problem is. I've been working in machine translation for 35 years now, and it's full of hard problems, and that's what makes it interesting. And then people come along and say, they kind of wave their magic wand and say, oh yeah, this is all going to be solved in no time at all. Then it's my responsibility and people like Xu Yin's responsibility to actually, put these claims in their proper context. So there is a thing called the singularity, and you may have heard of this. In 2005, Ray Kurzweil produced this book, and this was the essence of the next part of the talk, where I'll show you on the next slide. Jaap van der Meer, who is head of a think tank called Taus, more or less invoked the singularity and said that translators would soon become redundant. And there was a response to Jaap van der Meer's paper online, which you can still read, by Alan Melby and Christoph Kurtz, who said that if Kurzweil's singularity does arrive, there will no longer be a need for human translators, nor will there be a need for doctors or physicists or other professionals in our society, because machines will completely surpass humans in every intellectual tasks. Our lives will be so thoroughly disrupted that obviously translators will also no longer be needed. So, occasionally, like you will get your Sunday newspaper and you will read an article in that sort of glossy magazine that comes with the Sunday newspaper. And it's the march of the robots, how can we stop AI? It's going to take over completely. And this is what some people believe. And Jaap in his paper, really does, come out, here's a quote from his paper and says, the human translator is no longer needed in the process. And again, I would argue that that's not helpful, because it puts translators on edge. People who are attending translation training courses at university start to think, well, why am I bothering? If the AI is going to take over, there'll be no jobs for me at the back end. And that's hard for people like Xu Yin and my colleagues who teach translators in Dublin and elsewhere to actually convince students that this is still a profession worth becoming competent in. So I've taken some other quotes from his paper. He says our smartphones translate everything into our own language, brackets more or less. Well, it's one thing saying more or less and another saying that they translate everything. He says here, big tech companies are a competition with each other. They are. To try to build machines that can generate an unlimited supply of translations in as many languages as possible. Well, in as many languages as possible is not the same as all languages on the planet. It's not the same as saying that the human translator is no longer needed in the process. The obvious implication is that for those languages where high-class machine translation systems cannot be built, human translators will still be needed, you know. And the final, quote on this slide that by Van der Meer says that this only works when the engines are fed with the right quality and volumes of data. And I've asked you to think about whether you think for your application domains and your language pairs, and for many other ones that you might be able to sort of hypothesize, whether the right amount of high quality data is available for those scenarios. So another project that I've been supervising over the last 2.5 years or coordinating is the ELE project, the European Language Equality Project. We produced a book, which is freely available, open access online. Just type in ELE project book and maybe my name and you'll find it. All of the papers are there for you to download. It's freely available, open access. But one of the things that we found was we wanted to investigate what the real situation was for all of the languages of Europe. And there are about 90 of those. There are 27 official languages, 24 official languages, but over 90 languages in total. And this is our finding, unfortunately, except for English and to a certain extent German, Spanish, and French, all European languages are massively under-resourced in terms of data, tools, and technologies. So our assertion in the ELE project was that, unless the playing field is leveled, unless more data is made available and tools are made available in all European languages, then most Europeans who would like to operate using their language of choice are forced to operate through English, German, Spanish, or French. And that's not fair, so the playing field is not level. This is not a solved problem. So here is clear evidence that data does not exist equally for all languages across Europe. Now you kind of know this, but it's it flies in the face of some of the quotes by people like Jaap van der Meer. So here's a paper where the title is very promising. Towards the next 1,000 languages in multilingual machine translation. So the presupposition here is that there are already 1,000 languages in multilingual machine translation and I don't see any evidence of that. And machine translation works pretty well. I'm sure you all use Google Translate, like almost on a daily basis, or whatever your preferred MT system is. Maybe it's Baidu's system, or whoever system it might be. And you can use that satisfactorily, for a range of use cases, but it's certainly not the case at the moment that we've got high quality machine translation, between 1,000 languages. That's not the case. But, so the title is quite promising, but they had a couple of, I've put a couple of findings from that paper on this slide, which says that, for the 100 lowest resource languages, we found that our data was very noisy and had a lot of over-triggering with higher resource languages. And then lots of the data for certain languages simply did not accord with the language annotation provided. So for one of those languages, the label associated with particular data, for that language, when they actually investigated this, actually belonged to a different language. So if you just took that data associated with that language and tried to train up an MT system, it wouldn't work very well because a lot of the training data is actually from a different language than the one that you think it's from. And again, note that in Jaap's paper, he says that massively multilingual machine translation is a single model that can tackle any language pair in the world. Well, perhaps that is true in theory, but until the time comes that we have sufficient data sets to feed into that massively multilingual machine translation system, this, I argue, is a long way hence in the future, if it ever transpires at all. He puts great store on what he calls zero cost translation, but there's always some cost, So again, by interacting with freely available tools online, if it's free, that you yourself are you are being used, you are being mined. Data that you input into the system is being used to personalize adverts towards you, or to use your data that you input into these systems for suitable training or refining or fine-tuning of these systems. So there's always a cost. And one of the particular costs that I'll come back to later on that I have students working on at the moment is the environmental impact of training, ever larger models, with, we're going from millions to billions. We already have a trillion parameter model produced by Google, and this kind of space race cannot continue, I assert. Van der Meer says that the machine is totally dependent on the data, and that's let's see if that's true. He then talks about the need for cleaning of that data. That can't happen completely automatically. The next two bullet points are to do with domain adaptation, and again, people like me or Shu Yin work on these topics, and we know how to do this. But again, it requires human involvement. It can't happen completely automatically. And he is right in the fourth bullet point that context-aware machine translation is something being studied at the moment. It is, if you like, just around the corner. But again, that requires human involvement. It's not happening completely automatically by tools like ChatGPT. So is data the new oil? Again, is an analogy that he includes in his paper. And that may be accurate, but I'm showing perhaps that it's accurate not in the way that he thinks. So there are not many countries on the planet that have oil, and in the global worldwide problems that we have at the moment, we've all been hijacked recently by those countries that do have oil and been forced to pay higher bills for petrol for our cars, home oil and gas to heat our homes, etc., etc., etc. And in exactly the same way, we could easily be held to ransom by the 4 large multinational companies who seem to be the custodians of these large language models, and they could easily start to charge us huge amounts of money. They are already a large revenue stream for companies like OpenAI, where Microsoft has invested billions of dollars into OpenAI. Because it sees it as a large revenue maker. As I've already said, we have this kind of space race at the moment towards ever larger models, and that can't continue, I assert, because of the sort of greenhouse gas emissions which accompany, large clusters of GPU machines being, hammered 24 hours a day by these large multinationals. So we need to start to legislate, and stop those companies in their tracks, because they don't care about these things. They might pretend to care in the papers that they write, but they are only beholden to their shareholders. So they're just trying to make more and more money for their shareholders. Yaps also says in terms of data, time and again, MT developers always come to the same conclusion, i.e., that more and better data is always more effective in generating better results. That is not the case. I have for my group, and many others can come up with similar examples. I have lots and lots and lots of examples where we interact with smaller companies or the government, where we build machine translation systems which outperform Google Translate, for example, because the domain that we're asked to build the system for is very well described and ring-fenced, and we are able to come up with data sets that Google and Microsoft do not have access to. So that's the end of my sort of response to Yap's points, criticizing Yap's view of the world. But I'm not the only one that thinks so. And again, I'm not trying to put myself in the company of Jeff Hinton, who, as it says here, is one of the godfathers of AI. But he himself, again, you can see all of these screenshots from newspapers are quite recent. You can see here, this is May 2023. So only in March 2023, the 2 examples I gave you, it showed that ChatGPT was a marvel. And here we have one of the godfathers of AI, Jeff Hinton, who was the person behind backpropagation, which is the technique that we all use in our NMT systems to tune our NMT systems to make them better, to percolate back the error through the system and then retune the parameters and try to get better output. And he's saying that there are dangers inherent in AI. They're quite scary. and they could be exploited by bad actors. Again, this is April. ChatGPT was banned in Italy over privacy concerns. They were threatening to fine ChatGPT 20 million euros unless they satisfied those privacy concerns. They wanted to know, the Italian government wanted to know where ChatGPT was getting its training data from, and threats were made in that regard. ChatGPT is now available again in Italy with those privacy concerns having been met. The US social news and discussion site Reddit has come up with a new set of terms and conditions, effectively banning the mining of its websites for training of large language models and neural machine translation. So what it says here, you can look at this afterwards. I've given a copy of the slides to Shu Yin, and she will share those with you later. But essentially here, what they're saying is that people who intended to mine Reddit to extract that data need to get the consent of every single person who has produced data and put it up on that website. And clearly that's not viable. The Guardian, again, this was September, so just a couple of weeks ago, saying that it has blocked ChatGPT from trawling its content, and many other newspapers have done the same. Some of the claims to me are a little bit perplexing. So this is quite a famous guy on Twitter, Orenezioni. Again, I didn't put the date here, but you can find this tweet online. And he makes a bizarre claim to me, a completely inappropriate claim. So he says, 3-digit addition is performed accurately by ChatGPT. This is, version 3, less than 1% of the time with a model with less than 6 billion parameters. But this jumps to 80% accuracy when you have 175 billion parameters in your large language model. Now, 80% accuracy for 3-digit addition, to me, is still very poor. And it's not the sort of thing that ChatGPT should even be doing. I don't know when you were taught in school to do 3-digit addition, but I can do it, 99.999% accurately. And I could do that when I was probably about 10 or 11. So why ChatGPT is even being used for this inappropriate task is beyond me. And why commentators like Ezioni here are astonished at how good performance is when it's actually not very good at all is astonishing. AI and ChatGPT is being used not only for good but for nefarious purposes as well. And you may have read in the news that so Paul Michael Schumacher, a famous racing driver, is still in a coma, and a particular magazine, Die Aktuelle, in Germany, faked an interview with his family. And so the editor got the sack, and this magazine is being pursued by the family because they used ChatGPT to fabricate an interview with Michael Schumacher, and clearly he's not able to talk at the moment. So that's very, very insensitive. Here's another example in April of somebody winning a prize for a photograph that they made. But later on, they were exposed, and the winner of the competition had to admit that the photograph was actually generated by AI. They also said that this was being used to test AI. They wanted people to be aware of the dangers of using AI, but then I would say they would say that, wouldn't they, having been caught? Here is so I've got a set of graphs that in the next few slides, all available from that website that you can see at the bottom of the graph. And essentially, it's trying to show you perhaps that fewer people are using ChatGPT than before. So again, as a reminder, earlier in the talk, I was showing that ChatGPT in some people's eyes was a marvel, and that was only in March 2023. But you can see from a high point of May, in June and July, performance is starting to tail off. There are fewer and fewer visits to ChatGPT. Now, look at the numbers on the y-axis. They're still very high numbers, but it's clear what the trend is. And here, is the same numbers broken down for devices with 1 to 2 visits, with 3 to 10 visits, and more than 10 visits. And you can see that from a peak of around April, May, whether it's one-time users or multiple users, multiple visitors, the trend is the same. Fewer and fewer people are using ChatGPT now. I don't often agree with Republican politicians in the US, and here perhaps is perhaps the most insulting comment applied to ChatGPT so far. So just a few months ago, it was a marvel. It was going to take over all of our problems. It was going to, humans were not going to be useful for anything because ChatGPT was going to surpass us in a range of tasks. But Chris Christie, one of the Republican candidates, hoping to be the Republican candidate up against Trump in the 2024 election in US, came out in one of the presidential debates very recently, a couple of weeks ago, and said, "I've had enough already tonight of a guy, Vivek, one of his opponents, who sounds like ChatGPT." Okay, so now ChatGPT is being used as an insult rather than as something that is fully coherent and can produce fantastic content for us. It's a big thing in Ireland. Here's a few sort of screenshots from various websites. So it's been, ChatGPT authored articles have appeared in our main newspaper, the Irish Times, and our main broadcaster, RTE, regularly, puts news items on its web pages, showing recent developments. And again, I just added one in just this morning. You can see this this was published at 9:20 this morning. If you look at the website, sorry, 9:57 even, 9:57. So only about an hour before I started talking to you. The government were going to come out with a new curriculum for the exam called the Leaving Cert that students in Ireland do when they're 18. So this is the final exams that they do before they go to university or before they go and work for industry. And they have now shelved those plans because of concerns over AI. So what they wanted, to have was teachers marking their own students' work. And now the government is afraid that a lot of those students would use tools like ChatGPT to produce work. The teachers themselves would not be qualified to actually see whether that had been produced by the student or by ChatGPT. And they would give it a high mark where perhaps, a much lower mark was deserved. So that has impacted on government policy, even today in Ireland. So, if we're looking at the trend, for ChatGPT being downwards, what's it actually being used for? And again, here's a range of things on the slide. And again, it's perhaps a bit small for you to see. The leftmost pink bar in the chart is for programming. So it's being used, most of the requests for ChatGPT are programming related. People are asking ChatGPT to write code. But all of those things are amalgamated into this pie chart on the next slide. So you can see there nearly 30% of the requests to ChatGPT are programming related, 23% education. The ones I want to look at are the ones on the left-hand side of the pie chart. So 20.79, and sales and marketing, 13%. So around 33%, 1 in 3 requests to ChatGPT is related to sales and marketing or content related. So, I'm trying to now do a little bit of, sort of high-level investigation into how much ChatGPT is being used by people to do translation today. So, clearly, sales and marketing is not good material, so you would have been told by Shuyin and others that, rather than using, translation there, we use a technique called transcreation, rather than translation per se, because sales and marketing is not good material to use machine translation for. So looking at the content then, the 20.79, and breaking that down, you know, on the same website, you know, they investigate what are the most common words being included in ChatGPT prompts. And there are 40, I think there are 40 here, or 30, I think, most common words here. And you know, English is there, but no other foreign languages. The word translate or translation is not there. So, you know, I know that ChatGPT is being used for translation because some of my students, 3 of my PhD students, are using it, you know, to test how good it is for you know, translating different languages. So it is being used, but you know, you would expect if you were a translator and you were fearful for your existence, you'd expect the word translate to be there in the top 30 words, and it isn't. But here's the bad news. ChatGPT or large language models are actually very good at producing, you know, high quality output in translation tasks. So on this slide and the next slide, so I've got our performance. We participated in 2 shared tasks. These are competitions run by organizers who give you data, and then you take that data. You're not allowed to use any other data. So I can take that data, and anybody else on the planet can take that data. We build machine translation systems with that data. And then the system or the challenge coordinators evaluate the output from each of the machine translation systems which are participating in this task. And then they tell you where you came in the list. Were you first? Were you second? Were you last? Whatever. Now, we happen to win a couple of tasks. For Irish, you might expect us to win that. But also for the Indian language Marathi, and again, that's on the next slide. The system that we actually put forward for participation in the workshop, in the shared task, is the second system from the top in the topmost table. So it says adapt COVID extended. So blue, TER, and CHRF are different evaluation metrics, and you can see our performance for blue and CHRF. Those are precision-based metrics, so a higher score is better. TER is an error-based metric, so the lower score, the better. Okay, so you can see that, you know, we won that competition with a blue score of 36. We retrained a new model, a large language model, with the same data, and we got a much higher performance. So even though we won that competition with a regular, you know, NNT system, our large language model outperformed that. You know, for Marathi, again, similar performance gains were seen. So what I want to say is that large language models or multilingual large language models can produce high quality output. And so I think, you know, people who are system developers who rely on, if you like, old neural technology had better change to using, you know, multilingual large language models fairly quickly if their systems are not to become redundant. Just a word of warning, we had this through our email. It was an application for a PhD in DCU. It came into a colleague of mine, and she shared it with me, and we had a look at it to see whether we thought this was, you know, bona fide, or whether it had been produced by a large language model like ChatGPT. And, you know, so this was a student coming from a different country saying, I have a fully funded PhD. This is what I want to do. But, you know, on, you know, investigation by a couple of experts, we were able to see that this was not written by a human being. It contained inconsistencies. It cited papers that, you know, saying that the author said such and such a thing, which they really didn't say. And it invented some of the references in the bibliography. Now, you know, I've supervised many PhD students, you know, over the years. And because you're going to work with somebody for 3 or 4 years, you know, that relationship, like many other long-term relationships, is built on trust, you know. So there is no trust if you were to take on this particular student applicant, you know, because you know from the word go that, they haven't been truthful with you about, producing or who produced this content. So this is what we want to go to, explainable AI. And I just want to make some final points, as I finish off and allow you time for questions. We need to understand what large language models are good at, but more importantly, what they are bad at. The head of ACL, the Association for Computational Linguistics, the current president, says she calls them bullshit generators. They just make shit up, and they do. There was a case in the US where there was a lawyer who was obviously a lazy lawyer, didn't do due diligence, did his homework, was, before he went into court to try a case, was to look for legal precedents using ChatGPT. And his only due diligence was to ask ChatGPT, were all of these real cases? And ChatGPT said yes. So when it was shown in court that these were not real cases, obviously the judge got very upset with this guy, and he is in a lot of trouble for contempt of court. If large language models create sentences that make sense, it's because we, clever human beings, make sense of them. Yeah, they don't know what they're producing. So I have there on the top right-hand corner, if I paint a smiley face on a rock, it doesn't mean that the rock is happy. Yeah, the rock is still a rock. I'm not adding sentiment to that rock by just painting a smiley face on it. So, it's us being clever, not the systems. I've made this point already, so I'll the final point there on that slide. And even some of the large multinationals are saying that they don't have any special sort of techniques up their sleeve compared to the open source community. So the open source community are making large inroads on what the four large multinational companies who are the custodians of the large language models at the moment are actually producing. So watch this space. Let's see how the open source community, which feature many more people than are working in these companies on these topics. And again, lots of these people are very clever people, are coming up with all sorts of clever ways in which we can try to make inroads on these large language models. So what about the impact on translators? Well, I think it's hard to predict, but I think as MT systems become better at recognizing when its input is good or bad, if it's produced a bad translation, it won't show that to human translators, so you won't have to post-edit it. The problem is at the moment, or up until recently anyway, the way that post-editors have been working is, they are showing the output of all the MT systems, all of the MT systems output for every single source sentence in the document. And again, sometimes you see really bad translations, and you start to think that the MT quality is nowhere near as good as it should be. I think there'll be increasing demand for spoken language translation and multimodal translation in general. But again, if there is a lack of data for many languages and many use cases for text data, you can imagine how hard this is going to be for spoken language data and multimodal data. I think more literary translation will involve machine translation. This is a sly way for me to give some publicity to a book that is coming out very soon, which features a very good chapter by Xu Yin related to computer-assisted literary translation. So I'll move swiftly on, but that book is coming out soon, and we hope that you like it. Machine translation will improve for hard languages and resource poor scenarios. Lots and lots of people are working on this topic now. We're all using the same technology, so problems are being solved fairly quickly. Interactive machine translation is improving all of the time. So there are systems out there that, as you are typing, they try to predict. They try to complete your sentence for you to speed you up, to make you more efficient. So that's improving all of the time. There's a company called Lilt that bases its business model on that. Adapting machine translation to translator edits is easy and helpful. We've done experiments which show that interacting with an MT system is beneficial for human translators and post editors, because the system can learn what sorts of edits the translator makes and start to produce translations containing those edits so that the human doesn't have to make those edits anymore. Ultimately, of course, I believe, my first degree was French, German, and linguistics, so I'm a linguist. I believe that you can't do machine translation wholly without input from linguists or translators. I am astonished, as someone who's been doing machine translation for 35 years, I'm astonished how good MT output is at the moment when it's just mathematics. Everything is turned into, all the words are turned into numerical representations. And there's lots of multiplication, matrix multiplication that goes on. And there's next to no linguistics in these systems. But I do believe at some point that if we find a clever way to smuggle in linguistics, that the quality, we will break through the current performance ceiling. So to finish off then, there's no doubt that NMT has improved quality, that large language models are starting to improve over NMT bespoke solutions. We've got evidence ourselves from our own experiments that show that to be the case. But there are large numbers of languages and sectors where there is no data, or there is only small amounts of data. So talk of this being a solved problem are ridiculous. People have started, maybe the honeymoon period is over. People have started to push back against, tools like ChatGPT, saying that they're not as good as as people claim them to be, and that we need legislation actually to make sure, what use cases they're being used for good rather than for evil. We need to not overhype the technology, because then people are disappointed when they come to use the tools. And responsible, explainable AI is the future. My final slide then is a tongue-in-cheek. You can look this up. It's only a 3-page article online. But what they have done is, in terms of sort of the old Greek philosophers, this author of this short report online, which is tongue-in-cheek, assuming that there are no humans anywhere, that ChatGPT does everything for us. The philosopher the name that they have come up with is mediocrities. Yeah. So rather than companies saying how good their large language models are, obviously the pun here is on mediocre. They are useful, but they are nowhere near as good as people say. Thank you very much.
Thank you. Thank you so much. Thank you, Andy. Thank you for sharing your insights with us. It's truly inspiring and thought-provoking. I like the final bit, the pun one. So funny. So let's now start the Q&A session. Please feel free to raise your hands or type your questions in the chat box.
And it would be nice to see some faces as well.
Yeah. You can just turn on your cameras.
Hello, Professor Wei. Can you hear me?
Yep.
Hello, I'm Ke Hu from CU Education Shenzhen, and I'm also a lecturer in translation technologies. And I have been following your works on MT development for years, and I really admire your work. And thank you so much for your insightful and informative session. So my question has something to do with the point that you mentioned, the model versus NMT. So I think since the large language models are doing a quite nice job on the MT tasks, do you think this new type of AI technology, the large language models, will sentence the end of NMT, just like NMT sentenced the end of the PPMT? Would in the near future, do you think all the NMT systems will be replaced by the large language models?
Okay, that's a good question, and thank you for your kind words at the beginning. Obviously, people like me and Xuyin are asked to predict the future, and it's very hard to predict the future, as you know. Things change very, very quickly in this field of AI. But I suppose if I had to put a bet on something, I would say yes. That the large language model, the multilingual large language model approach will probably overtake. I've given you some evidence that the performance is better for certain tasks. what's really good about these models is that you don't need large amounts of bilingual aligned data that you needed for SMT or for bespoke NMT systems. So, what we've managed to show, what people have shown with the multilingual large language model approach, is that good quality translation can ensue for languages which are included in the training, but for which there is no direct or very little direct aligned data. So I think that's a huge benefit, especially for under-resourced languages and language pairs, and under-resourced, application scenarios. So, at the moment, people would struggle to build good quality MT systems for those language pairs and for those for those use cases. But given the benefits of using the multilingual large language model approach, that's a way of partially solving those problems.
Okay, thank you very much. I got you. So my follow-up question would be about domain adaptation. So for NMT or PBMT, we can do domain adaptation so that the MT system will specialize in a particular domain with the training of data from that particular field. I wonder if it is possible to do domain adaptation for a large language model so that the model will be better at translating a text from a particular field, let's say legal text or medical text.
Yes, yeah, that's doable now, and people are doing that now. And really, that's the only thing that they can do. So like, given how large these multilingual large language models are, like you or I can't build a trillion parameter model. We don't have access to that amount of data and that amount of GPU. It costs us a fortune. So Google makes billions and billions, hundreds of billions of profit every year. So it doesn't care. It just fires up more and more GPU systems. And as I say, there is a negative impact on the climate, and we all know that the planet is in a difficult situation at the moment. So I think that we in NLP, we need to be responsible citizens, like we're asking people in other areas to be good citizens. So the only thing that we can do with those models at the moment is to tune them. We can't build them, we can only tune them. So we can take one of these large language models, and with our own in-house data sets, we can tweak the performance and see if performance improves for our particular data set that we have. But we can't build a big enough model ourselves. So I think that's a problem at the moment. And I think that's a question that we should all ask ourselves. Are we happy for, let's say in 5 years' time, the only models on the planet to be owned by Google, Microsoft, Facebook? Is that what we want? Is that a good state of affairs? And you by my asking the question, what I think. So yes, that can be doable at the moment. People are doing that. And I would argue that it's the only thing we can use these large language models for at the moment. We don't have the capacity to build as big large language models as these multinational companies, of course. So the best we can do is to tune them ourselves.
Okay, thank you. I think you are absolutely right. So my final quick question. So is there any difference between domain adaptation for NMT systems and domain adaptation for the large language models? I mean, the training data behind the large language models like ChatGPT are huge, much larger than the data behind DeepL or other NMT systems. So if I use, let's say, 1 million characters in domain data to train an NLP system, I will get significant improvement. But for the large size of data behind, generic data behind a large language model, would 1 million or 2 million characters of data be like a
Okay,
that's my question.
Okay, yeah, okay. You froze for a little while there, but I understood the question. I'll say one thing, and again, it's related to the dangers of using these large language models. Is that with ChatGPT 3, OpenAI were happy to say what training data they used to build that model, but with ChatGPT 4, they are no longer saying what data they are using for training those models. So you could be trying to tune ChatGPT-4 with your data set, but that data set might already be in the training data. And we know that, that your test data or your tuning data can never be or should never be part of your training data, because it skews the results. There's a bias in the results that we get. So that's a big danger. And I think that's one difference between using these large language models and actually trying to tune a bespoke NMT system that you could build yourself. So you could take one of the online platforms, put your data in, or take an NMT system that's already been built, add in, as a final layer in the network, your data, and see if the translations improve or if they get worse. And that way you can actually make sure that your data is different from the training data. And this way, where we're beholden to these 4 big multinationals, they won't even tell us anymore what data they're using to train their system. So we all have a big problem there.
Okay, thank you very much for your helpful answers. That's all my questions. Thank you.
Thank you, Huke. Thank you, Andy. Any other questions?
Yes, please. May I?
Yes, please.
This is, thank you. This is Amal Al-Hadari. I'm an educator and a premier translation provider. I have my own trade secrets when it comes to machine translation and translation memory. First of all, I teach at Ain Shams University, and I'm a Yale associate and University of California, Irvine affiliate, a graduate of Edinburgh University. Thank you very much for a very illuminating talk, and indeed you have provided excellent knowledge we all need at this point. As a premier translation provider, I have my own trade secrets, and we all hesitate to share them in the market. In the meantime, I have a theory, and please do challenge my theory if you wish, or support my theory. The theory is human translation, at least as a top revisor, shall always prevail. I repeat, I acknowledge that machine translation and translation memory are achieving great progress. However, they can be a disaster without the maestro, the leader, the top translator, who will revise and adjust. Thank you.
Yeah, I agree with you 100%. I mean, I always try, over the last maybe 10 years, I've tried to speak as often as I can at translator conferences and try to reassure them, as I'm trying to do today. I hope you get some reassurance from some of the things that I'm saying. I'm offering a sort of a more, I hope, balanced view of what the capability of these systems is, and to try to show translators that no matter how much MT, however it's done, no matter how much that improves, there will always be, the human translator will always be the most important cog in the chain. Yeah. So I mean, I'm very happy to stand up, and I've done that on many occasions, and I agree 100% with you that we will never. I mean, there are lots of situations where you can't have human intervention, where MT can be useful as a standalone. Like if you're in a foreign country, you can't pay for a human translator to walk around with you all of the time and translate things for you. Most of us can't do that. So we can rely on Google Translate, to do a reasonable job there for us, although it doesn't work perfectly. But for many application areas, it is vital that there is a human at the back end to check the output. Anybody who publishes NMT data, without having that checked by a human is crazy, in my opinion.
Absolutely. Just a follow-up, please. The big surprise today was what you mentioned about Chat GPT. Is there a future for it in translation, or is it limited, or something like a farce?
No, I don't think it's a farce. I think it has potential. But what I was trying to show is, at the current time, it doesn't appear, just by looking at the keywords in the prompts, it doesn't appear as if people are using it for translation very much, or as much as we might expect. Or, I'm trying to show that, if Jaap van der Meer is saying that human translators will be redundant very soon, it doesn't seem already that people are using ChatGPT to do translation in sufficient volumes to put all human translators on the planet out of work. So I think what I'm trying to do is show that his claim does not hold water.
Thank you. Thank you very much. Thank you.
Okay, thank you. So that's another question from Nesma. Nesma says, thank you for the informative talk and lovely presentation. I would like to know, how can the ethics of using translation technology be addressed in a PhD thesis? How to go about it scientifically? I tried in a small study, but it felt like proving that water is wet.
Yeah, so sorry. So while Amal was asking me the question, I was trying to type into the chat a bit of an answer. So yeah, I mean, there's work on that. There's even a book. I look after a series of books on machine translation by Springer, and there is a recent book out on the topic of ethical machine translation, responsible machine translation. I'm trying to see if I think I have it here. Yeah. So I don't know whether you can see that.
Yes.
Yeah, towards responsible machine translation. So it's by Helena Moniz, a Portuguese linguist, head of the European Association for Machine Translation, and Carla Para Escartin. And it has topics on, yes, that's the one. Thank you very much, Elizabeth. That book is available. Again, if it's too expensive for you and you want to read certain chapters, there are ways and means by which we can share certain chapters with you. So if you're a poor student, let me know, and we'll try and get some of that content to you without Springer knowing. But yeah, the other work that I cite there, the work on Fair MT by Dorothy Kenny, Felix de Carmo, Joss Morkins, etc., that's freely available. So if you search for Fair Machine Translation, you can find that data. There have been workshops looking at the ethical concerns, looking at the downward pressure on price that translators have had to struggle with for many, many years. Okay, Liz is doing a great job for me here. She's giving you all the references in the chat as I speak. ChatGPT couldn't do that, Liz. So as well as you're doing it. So fair play to you. But so I'm trying to show that there are people are taking this seriously. I think it's good that people are taking this seriously, because it's clear that translators have been abused, if you like, in the past by the appropriation of their data, and also by being forced to work for very low rates of remuneration, and that's not fair.
Okay, thank you so much. Thank you, Andy, for sharing with us these articles and books. So I think it's now already 7:30, actually 7:33. So shall we call it today? Thank you, Andy. Thank you so much for your time and delivering this inspiring lecture. I hope we can meet each other one day in person. And thank you all for joining us in this enlightening session. I hope to see you all in our next lecture. Thank you.
Thank you very much.
Okay.
This was great. Thank you very much.
Thank you. Thank you, Sheehan, for inviting me.
Thank you. Thank you for coming. Thank you. Thank you so much.
Okay. Bye-bye.
Okay. See you. Bye-bye.
Bye-bye. Bye-bye.